this problem, we're going to calculate the maximum loading P for a bar supported by 3 metal rods. To start, we're going to draw the free body diagram of the beam itself. Remember to replace each rod with the corresponding support reaction. While we don't know P, we're going to treat it as a constant using the variable P itself. Now we're going to perform a static analysis to obtain our equations of equilibrium. I'm going to sum the moments about A and the moments about E. This will give us 2 equations of equilibrium for the problem that we have. With only 2 equations, this becomes statically indeterminate, and we need to create our compatibility equations to be able to solve for the 3 unknowns. To create the compatibility equation, we need to find out what the displacement of the beam is, and we consider each point A, C, and E, and see how they displace once the beam is under load. A displaces by a certain amount, C displaces a little further, and so does E. Because its displacements create triangles, I am going to find what the sides of the relative triangles made by the new points of A, C, and E are. So I find the relative distances of the new location of C to A, the new location of E to the new location of A. Since we know the horizontal length of the beam, we obtain 2 similar triangles. Then the compatibility equation becomes the adjacent side of one of the triangles divided by this opposing side, and the adjacent side of the larger triangle divided by its opposing side. From here we can simplify the equation so that similar terms are grouped together. And we can substitute with the corresponding known values. I am leaving L and A as constants because they are the same for all rods and they're going to cancel out. At this point, we can take our 3 equations and group them together into a system of equations that we can solve. We haven't solved for P yet, but all our support reactions for each rod are in terms of the variable P. Using the constraints from the problem regarding the allowable normal stress, we can then calculate P for each rod. We see that we don't need to calculate the maximum P load for EF and AB, since AB will yield a much larger P than EF, so we just choose whatever yields the lowest internal load between the two, in this case 82.99 kilonewtons. From here we do the same thing to the steel rod. We calculate the maximum allowable P for that case. We see that the lowest value of P is the maximum that the system can support without any of the rods breaking.